Yes, today we're going to be solving a quantum mechanical system. This is a stationary system where we have our psi right here. This is our psi right here. This is our function right here. This is the potential energy of the function. B is just a constant. C is the length, and M is the mass of the particle. What we need to find is the energy of the particle. So the first thing that we need to do is find our time-independent Schrödinger equation, which is negative h bar squared over 2m times the second derivative with respect to the function psi of x over dx squared plus the potential energy times psi over times the function psi of x, and this is going to be equal to the energy of the particle times psi of x. And we know this is the Hamiltonian, right? The Hamiltonian acting on psi of x. This will return back psi of x. You're going to see that it will return it back plus a constant. And that constant is what we're looking for, which is the energy of the particle, okay? So let's go first find the second derivative, right, of the function, okay? And our function, psi of x, right, is b times x times e to the negative c x squared. Okay, first we need to get the first derivative, right? So this is going to be, we're going to leave bx alone, so this is going to be negative 2 bz x squared times e to the negative c x squared. And then now we're going to take the derivative with respect to b of x right here, which is going to be plus b times e to the negative cx squared. And now we need to find the second derivative of this. This is our first derivative, right? Now we need to find our second derivative. And we know that it's going to be, we're going to live along the x squared. We're going to take it from over here. So this is going to be plus, right? It's going to be, we'll put this right here. Okay. We're going to take the second derivative right here. Let me write all of this right here. Cx squared e to the negative cx squared plus be to the negative cx squared. We're going to take the second derivative now. Okay, this is going to be, it's going to be plus negative negative. It's going to be 4 bc squared x cubed, right? Cube e to the negative cx squared. And now we're going to take the derivative with respect to x squared right here, to the cx squared. We're going to take the derivative with to this right here. And this is going to be minus 4, right? Minus 4 b cx e to the negative cx squared. And then we're going to take it with respect to this part right here, which is going to be minus 2b cx e to the negative cx squared. And what we're going to do, we're going to add this right here. -4 and -2 is the same thing. So we're going to add that up. We're going to get that. Once we simplify that derivative, it's going to be 4b c squared x cubed e to the -c x squared minus 6b c x e to the -c x squared. And now I'm just going to multiply by negative h bar squared over 2m. And I have all of this right here. So I know I can reduce this 2 right here with the 4 is going to give me a 2. And the 6 is going to be a 3, right? So I'm going to have that this is going to be 2b c squared x cubed h bar squared e to the -c x squared, right, over, this is m right here, over 2m, I'm sorry, over m, and this is going to be minus 3b c x h bar square over times e to the -c x square, also over m. Now I'm going to add my potential. My potential, because you see, it says plus the potential times psi, times the function of x. My potential is going to be plus 2c squared x squared h bar square, and I'm going to put it over m times my function, which is going to be b times x, b of x, e to the -c x squared is equal to e times psi of x, which is b x e to the -c x squared. Okay, what I want to do now is I want to divide everything, all of this right here. Right, b x e to the -c x squared. I'm going to divide all of this right here over b times x e, b x e to the -c x squared. And right here I'm going to do the same thing. It's going to be b times x times e to the -c x squared. And right here I'm going to do the same thing. b times x times e to the -c x squared. And right away I can see I could cancel all of this right here. I can go ahead and cancel all of this right here. I can go ahead and cancel this b. I can cancel this x right here, and I can cancel all of this right here. So I can cancel the b and the x, and all of this right here. And I can go ahead and cancel this here. This x cubed, right? I can cancel an x. It's going to give me an x squared. I can cancel all of this right here. And I'm going to get, instead of x cubed, it's going to be x squared, okay? And the b also cancels. So what I'm left with is going to be 2c squared x squared. I'm going to write the h bar in this form. H over 4 pi. Remember that h bar is equal to Planck's over 2. It's called a reduced Planck constant. Is h over 2 pi. at a square. So this is going to be square right here, 4 pi times m, right? And then I'm going to do the same thing over here. Minus 3c x h square over 4 pi m, right? That's what I got here, plus 2. This is a negative right here, because I multiplied by negative h bar square over 2m, plus 2c square x square h square, which I'm going to write it as h square over 4 pi, and I have my m over here. You can see it over here, my m right here, and this is going to be equal to my energy. So right away I know I can cancel this and I can cancel this, so my energy is going to be what? It's going to be equal to 3. I was able to cancel this x right here. You can see that I was able to cancel this x because I have it over here. See, I have it here and I cancel it here. I just wrote it out by mistake over here. So I'm just going to go ahead and write h square. So this is going to be 3c h square over 4 pi times the mass. And remember, this is going to, pi is going to be square because it's h bar square. Okay, so pi is going to be square. It's 4 pi square. So now all I need is, okay, I got my energy. It's going to be equal to 3 times, what is my C? It's going to be, my C is going to be 2.00 times 10 to the negative 9, right? Nanometers, right? Then I got it in a square times my Planck constant, which is going to be 6.26 times 10 to the negative 34, and this is joules second, and it's going to be square also because it's square right here, all over 4 pi times my mass. And my mass, remember, because we have it it says that the mass is equal to 1.00 times 10 to the negative 27 kilograms, right? So you know that 1 kilogram is equal to 1,000 grams. So 1 gram, right, is equal to 0.001 kilogram. So I'm just going to come over here and put 1 times 10 to the negative 27 times 0.001 kilogram. So let me enter this. This should be equal to, let me enter this into my computer. My energy should be equal to 6.672 times 10 to the negative 20 joules. And remember, you got meters, second, kilogram. Dimension analysis, that's for joules. So that's my energy. So if you like this video, please hit like and subscribe. Thank you.